Today's lesson is on angles, and it corresponds with 8.5 in your textbook. And we're going to be talking about angle measurement and some of those types of things. And the first thing we need to just remember how to name angles. And if you look at the picture here, we can see that we have three different angles, the two little ones that make up the big one. Now, when we name angles, we typically use three letters. The middle letter is always the vertex. Occasionally, we can name an angle with just the vertex letter. But in this case, we can't. Because if I said angle M, you would not know if I was saying this angle, or the big angle. So therefore, this top angle, we would name angle JMK or angle KMJ. That's the same angle. So what about this angle down here? Angle KML, or you could name it LMK. And then the big angle would be angle JML or angle LMJ. Three angles, two different ways to name each angle. Now, if we go to these angles, we can see that, hey, we can name angle Q here because the angle everyone knows is Q is just right here. So that's okay. The other two ways, we would use the three letters, angle PQR and angle RQP. Number two is very similar to that. We can use angle Y again because we can tell that's angle Y. We can also use angle 1 because the book is nice enough to put a red number in there for you. Or you can simply name it with three letters using the vertex as the middle, XYZ or angle ZYX. So you can guess that this one is exactly the same, DEF or FED, or angle 2 or angle E. Okay. Now the protractor postulate simply says that we can make a protractor, we can divvy up all of the spaces equally and get 180 what we call degrees. Now before I move on, when we measure an angle, if we put the crosshairs on the vertex and we have the side of the angle going to the right, we read the inside numbers. If we do this the other way, we read the outside numbers. So it all matters where 0 is. The other core concept today, acute, right, obtuse, and straight. Acute angles are less than 90. Right angles are equal to 90. Obtuse are larger than 90, but less than 180, because a 180 degree angle is a straight angle. So let's measure some angles. What is GHK? Well, GHK, 0 then, we're to the left, so we're reading the outside. GHK then looks like it's about 125 degrees. Then we're supposed to classify. Is it acute? Is it right? Is it obtuse? Or is it straight? It's more than 180, but less, or more than 90, but less than 180. So that is obtuse. What about JHL? Easy, right? 90. So that is a right angle. And what about angle LHK? LHK. Well, if this is 10, 20, 30, looks like 35 degrees. Looks about 35, doesn't it? We count 10, 20, 30, and a 5. So that's acute, less than 90. All right, let's do some more. What about angle JHM? JHM. Now we're reading the inside. Looks like it's 145 degrees, so therefore that is obtuse. What about MHK? Well, that's 55 and 145. So 145 minus 55 is 90. So that is a right angle. And then MHL, 10, 20, 30, 40, 50. Looks like it's 55. So that is acute. Now, we have a quilt with a bunch of little shapes here. Identify the congruent angles labeled in the quilt design. Well, look at the arcs. With lines, we use tick marks, and I'll admit it, I usually put tick marks and double tick marks for angles as well. So it's totally up to you. Your book does not. It uses arcs. So in this case, angle G would be congruent to angle B, and angle F would be congruent to angle D. Then it says if ADC is 140, what's EFG? Well, that's pretty obvious, isn't it? They're congruent. So that would be 140. And notice I use single letters here because we can all tell what those angles are, easily identified. Now, without measuring, is angle DAB congruent to angle FEH? I would say no as well. Now, looking at the pictures, I would say that this angle down here looks closer to 90, while this one definitely is obtuse. So reasoning being, those could not be the same. Okay, now, angle addition postulate. Much like the segment addition postulate, all this means is if you have a big angle and you put a ray in between it, then the smaller two angles that make up the big one, if you add them together, you're going to get the big one. So, given that, let's say angle LKN is 145 degrees. So that is all of that. So it stands to reason that 2x plus 10 plus 4x minus 3 is going to equal 145 degrees. Now, since all the x's are on the same side, we can combine them. And we can also combine 10 minus 3. So 6x plus 7 equals 145. I'm going to subtract 7. So 6x equals 138. We divide by 6. And I think that's 23. Now that isn't the answer, is it? Because we need angle LKM and the measure of angle MKN. So we need the two angles. So we're going to put 23 in there. So 2 times 23 plus 10 is 46 plus 10, which is 56 degrees. So that's 56 degrees. Now we can either subtract that from 145 to get this angle, or we can just plug it in just to see if it works. 4 times 23, let's see, 46, 92. I think that's right, 46 times 2. Can't do the math in my head. Yeah, it's 92 minus 3, so that should be 89 degrees. And is 89 plus 56 145? Yes, it is. So there's the two angles. Okay, now, given that angle KLM is a straight angle, find the other two angles. Well, that simply means that if we add these two together, we should get how much? 180, shouldn't we? So again, combining like terms, there we go. Add 2. 14x equals 182. Divide by 14. And if we divide those, we get 13. So then we can plug that in. 10 times 13 minus 5 is 130 minus 5, which is 125 degrees. Now we can just subtract that from 180 and get 55, but we should probably check it. Does 4 times 13 plus 3 equal 55? Yes, it does. So 125 and 55. So on 9, if we have a right angle, we're going to add them together to get 90. So 3x plus 3 equals 90. Subtract 3. 3x is 87. Divide by 3. Let's see, it'd be 29, I believe. So then we just plug 29 in there. 29 plus 1 is 30. So that makes that 60. And we're done. That's as simple as I can make it. Okay, now these last two we're going to have to think about. We've got some terms we're going to throw in before we solve them. First of all, ray QS bisects angle PQR. Okay, so let's just draw PQR. When in doubt, draw a picture. Now it says ray QS bisects this angle, so it cuts it in half. So I'm going to try to cut it in half as much as possible, easy as possible. Okay, then it says angle PQ, I forgot S, didn't I? Angle PQS is 24 degrees. Well, then it stands to reason SQR is 24. I want to know PQR. Hey, 24 plus 24 is 48 degrees. But if you didn't know what this means, you wouldn't be able to solve the problem. So remember what bisect means. Now, angle MNP is a straight angle, okay? MNP. Ray NQ bisects this angle. Okay, well, what bisects 180? 90, right? So these arcs then, it says use arcs to make them equal, okay? But I think we know that instead of arcs, we should use squares, shouldn't we? There you go, 90-degree angles. Done. Now this exit ticket, can you do this? 3x plus 23 and 2x minus 40. We know that that equals 143. So I'll do it with you. So if we're going to add those together to get the big angle, we should get that right there, which is 5x minus, let's see, what's 23 minus 27? No, 17. That's 17 in it. And then add 17. Whoops, sorry. Add 17. 5x equals 160. Divide by 5. That's going to be 32. So we plug 32 in there. 3 times 32 plus 23 is 96 plus 23, which is 119. And if we take 2 times 32 minus 40 is 64 minus 40, which is 24. Does 24 plus 119 equal 143? And the answer is yes. This concludes